Unit 2, Lesson 2, Earth's Surface. We will be learning about erosion and deposition by wind, water, ice, and gravity. The first thing you'll be able to do is describe how wind speed affects sediment movement, how glaciers shape the land. You'll be able to describe the processes of erosion and deposition by gravity, creating mass movements, and you'll be able to define and describe rockfalls, landslides, mudflows, and creeps. Our 8th grade science standard is a combination of constructive and destructive geologic processes formed Earth's surface. Please do the bell ringer on page 117. Do numbers 1 and 2. How can wind shape Earth? When wind moves soil, sand, and rock particles, it acts as an agent of erosion. Abrasion, which is the grinding and wearing down of rock surfaces by other rock or sand particles, can happen in areas where there are strong winds, loose sands, and soft rocks. Look at this photo over here. This is the Arches National Park in Utah. This was created by, you guessed it, abrasion. The removal of fine sediment by wind is called deflation. Deflation usually leaves behind rock fragments too big to be lifted by the wind, creating a landscape known as desert pavement. On page 118, please do number 5. Just as water deposits its sediment over time, so does wind. As wind slows down, it's going to deposit its sediment into large areas, creating landforms. These mounds of wind-deposited land are called dunes, sand dunes. Dunes will usually move in the direction of the wind. Wind can also carry extremely fine material very long distances. Thick deposits of this type of wind-blown sediment are known as loess. This right here, this is loess. Loess deposits can build up over millions of years and are very valuable sources for farming as they are really, really fertile. Now, turn to page 119 and please do numbers 6, 7, and 8. Why do you think loess can be carried further than sand? What did you say? Did you say loess is smaller and finer than sand, so it can be carried away by slower winds? If so, great. If not, correct your answer. Number 7. Look at the photo above in the illustration. Which direction does the wind blow across the photographed dune? Is it going from left to right or right to left? The wind is blowing from left to right. Which side of the dune in the photograph is the slip face? A or B? Hopefully you said B. Now let's talk about ice. What kinds of ice shape Earth? Do you know what a glacier is? A glacier is a large mass of moving ice that forms by the compacting of snow by natural forces. The steeper the gradient, we know that is the slope, the faster the glacier moves downhill. Glaciers erode rock through abrasion, but also deposit materials through deposition. Here we have glaciers in Iceland right over here and over here. Glacier drift is the general term for all the materials carried and deposited by a glacier. So anything that was trapped in that glacier, when it slides down, anything that it leaves behind, that is called glacier drift, sometimes called glacial drift. Please turn to page 120 and do number 10. This right here are the glacial grooves at Kelly's Island in Lake Erie, Ohio. I actually went there last year and was able to take some pictures and videos of this myself. At some point, I'm hoping to show that to you. Have any of you guys ever been to Kelly's Island? This is a pretty cool feature here in Ohio. And then answering your question number 10, where in North America would you expect to find glaciers? Did you say far north in Alaska and Canada, as well as some on top of the peaks in the Rocky Mountains? If so, great job. If not, change your answer so you have the correct answer. This right here is a glacier just north of Juneau, Alaska. An alpine glacier is a glacier that forms in a mountainous area. So up here, this glacier is what we would call an alpine glacier. Glaciers might also form in valleys originally created by stream erosion that were forming a V-shaped valley. As glaciers go through there, they're going to widen and straighten the valley into a broad U shape. Here we have pictures of alpine glaciers. Horns are the very tippy top up here. They're sharp pyramid-shaped peaks that form when several arates join at the top of a mountain. Arates is almost like a spiky mohawk. They are the jagged ridges that form between two or more cirques that cut into the same mountain. And then a cirque, it's kind of hard to see here, but it's if you have a mountain and think of if you would take a mountain and you would make it out of clay, and then you took like a bowl and you push it onto the peak, you're going to get this kind of indented area right here. So cirques are bowl-shaped depressions where glacial ice cuts back into the mountain walls. And down here, we used to have a nice V-shaped valley that was very steep, but as the glacier goes through, we get a U-shaped valley. And that gets formed from when a glacier erodes a river valley. The valley changes from its original V shape to a U shape. Over here, we have hanging valleys. They're just small glacial valleys that join the deeper main valley. Many hanging valleys form waterfalls after the ice is gone. Features of an alpine glacier are cirques, horns, and arates. Point to the cirque. Here's the cirque. Point to the horn. Up here. This is the horn. And point to the arate. The arate is over here. It's like a little mohawk of spiky tops. Now, turn to page 121. Do number 11. Here we see all sorts of glacial features. We have hanging valleys. Hanging valleys. We have arates. This gives a better look at what an arate is. It's that long, like almost like mountain range peak. We have the horn, which is the tippy top. Truncated spurs, we don't really talk a lot about those. Triangular facets, we don't talk a lot about those either. And then this is the actual glacier going through. Now, back to those questions. On page 121, number 11, it says use the illustrations to write a description for each of the following landforms. You should know the difference between each four of these: an arate, a cirque, a horn, and a U-shaped valley. I believe these were in your vocabulary. Let's go with arate. An arate is a jagged ridge that forms between two or more cirques. A cirque is a bowl-shaped depression where a glacier cuts into a mountain wall. A horn is a pyramid-shaped peak formed where several arates join. And a U-shaped valley is a valley carved out by a glacier. Continental glaciers are different from alpine glaciers. Continental glaciers are thick sheets of ice that may spread over large areas, including perhaps over an entire continent or continents. Now look at page 122. Do number 12. These glaciers are smooth and round, and they expose rock to flatten the terrain. They leave it very, very smooth and round. They leave recognizable features like erratics and kettle lakes. Up here, we see an erratic. What does the formation of erratics and kettle lakes have in common? Both kettle lakes and erratics are the result of materials like large boulders and chunks of ice that were deposited by a glacier as it retreated. Up here we see an erratic. This large boulder was in the middle of one of those glaciers, and as the glacier melted, we then get this very large boulder in the middle of nowhere. And here we had a whole bunch of water. The kettle lakes form when chunks of ice are deposited by a glacier, and then that glacial drift builds up around the ice. Like this was all glacial drift at some point. And so then when the ice melts, we get a lake because it had boundaries on its Earth. How can gravity shape Earth? Gravity is also a major agent of erosion. Gravity can cause a lot of soil and rocks to move downhill, which is referred to as mass movement. Most slopes are undergoing slow mass movement every single day. Some movements can be slow enough that it's almost imperceptible. Over here, we see something. It's a vocabulary word. Do you know what that is? As the soil on this hill shifts, how is this tree changing so that it continues to grow upright? Why is it not growing sideways? The shape of this tree trunk indicates that creep has occurred along the slope. That extremely slow movement of material downslope is called creep. Creep. This is creep. The most destructive mass movements happen suddenly and rapidly. Can you think of any? Rapid mass movements tend to happen on steep slopes because the materials are more likely to fall down a steep slope than a shallow slope because of the gradient or because of that slope. A rockfall happens when loose rocks fall down a steep slope. A landslide is a sudden and rapid movement of a large amount of material downslope. Landslides can be catastrophic as they can carry away animals, vehicles, and buildings. Heavy rains, deforestation, construction on unstable slopes, and earthquakes can increase the chances of a landslide. Rapid movement of a large mass of mud is called a mud flow. That's what you're seeing right here, mud flow. Mud flow happens when a large amount of water mixes with soil and rock. Mud flows generated by volcanic eruptions are called lahars. Here is a lahar at Mount Merapi in Indonesia. Please turn to page 125 and do numbers 17 and 18. List 5 events that can trigger a mass movement. Did you say heavy rains, deforestation, construction on unstable slopes, earthquakes, and volcanic eruptions? If so, great job. If not, write down the correct answers. Now let's look at number 18. Look at those two pictures. On which slope, A or B, would a landslide be more likely to occur? What do you think? Did you say B? Yes, because it has a steeper slope. Why aren't there mass movements in Florida? That's your lesson on erosion by wind, ice, and gravity. I hope that this has helped you understand the concept. Make sure that you answer all the questions completely, and I'll see you in class.